Passwords and things. Well, it might be a colossal effort, but we're going to try anyway. There are a number of ways that you can actually connect to your switch or router. For Cisco, you can use the console login using the Cisco Blue console lead to the console port. Perhaps alongside that port you've got a black coloured port, which is the auxiliary port. It's not fitted on all devices, but you can use the same lead, or perhaps I give you a black lead. Looks like a flattish sort of cable. It's exactly the same as the Cisco Blue, it's just the colour that's different. The pinouts are the same. So that's just simply a serial port login into the device. Now the console port actually doesn't need a password, but the auxiliary port does, and that's certainly true if you want to raise the level that you've got from the user exec to the privileged exec level. The privileged exec is also known as the enable level. That's because you use the enable command to go from the user to the privileged level. That can be further password protected. Now, if the auxiliary port does not have a password set, then you can only go in at the user level. You can't raise up to the privilege level. Whereas the console port, you can actually go in at the user level, type in the enable command and get to the privilege level without the need for a password. Passwords that you have, remember, include the login password. Now the console port doesn't need a login password. Like AUX, Telnet requires a password to be set. If there's no password set, then what you'll find is that you won't be able to access the device using remote login. Back to the auxiliary port. The auxiliary port doesn't actually need an auxiliary password. If there's an enable password set, the AUX port will actually use that and allow you to get in, essentially, and you'll be able to use that port. So whilst the provisor is the AUX port needs a password, it doesn't actually need an AUX login, although you should. And if there is one, it'll test for that at login. We're going to use some Cisco equipment for the purpose of today, so we need to connect our laptop or PC in. So we'll use the Cisco Blue cable. This one's got an RJ45 at one end and a 9-way D-type at the other. There are some variants. I only have a USB port, so I need a USB to 9-way D-type converter. So let's plug that into the laptop using one of the spare ports. There's the 9 pins. That'll connect to the 9-pin D-type, the female end. So let's plug that in. Now let's take the other end of that cable. Now that's in. There it is. Take the RJ45 and present that to the equipment rack. Now these have 9 ways. So notice the console and the auxiliary port look the same. Just the Cisco Blue or the black to identify them. They will accept the same cable. So let's go into the console port first. That matches the colour nicely. So once the blue console lead or the auxiliary port is connected, you'll need a suitable application that supports serial communication such as Hyperterminal or PuTTY, and that needs configuring. The settings should be 9600 baud, 8 data bits, 1 stop bit, no parity bits, and flow control set to X on, X off, or none. Perhaps try the first and see if it works. Press return and you may be requested to enter a login password. Alternatively, you will be raised immediately to the user exec level. This will be represented by the prompt on the left hand side of the screen containing the router name and a greater than sign. Follow this by typing enable to raise yourself up to the privilege exec or enable mode level. You may again be asked for a password, and on successful entry of that, the prompt will change. Instead of a greater than sign, you'll now have a hash symbol. You can do lots of commands at the user exec, lots of show commands, not as many as you can actually perform at the privileged exec. You can also move information around in terms of you can make backups and restores at the privileged exec level. But for most of the configuration commands, you're going to need to move to global configuration. And to do that, simply type in configure terminal at the hash prompt. That's abbreviated to config T, and you'll know that you're at the right level because the prompt will now change where you've got the router name and then in brackets config followed by the hash prompt. You'll probably then go into several other levels such as interfaces and complete configuration commands at those levels, and when you're finished you'll need to come out of those levels either one at a time, so one level at a time using exit, or all the way back to the hash prompt using Control Z. It's very useful because then you can execute some of the show commands. However, you can execute some of the commands that should be performed at the enable level at other levels, and to do that you use the do command. So you precede the command with do space and then the command as you would do at the hash prompt. So Control Z back to the hash prompt. Now if you want to move back to the user exec level, then you do the opposite of enable, which is disable. You can simply type exit at this point. From the user exec level, you can log out or exit out, and you'll then once again have to go through the login procedure by pressing return to start that once again. Right, so let's see that in real life. We're going to log on to router B, so press return. Got the router B prompt. It's the greater than sign, so we're at the user exec level. Type in enable. We've been prompted for a password. In this case, it was Cisco was the password, and we can see the hash prompt is our reward as we move to the enable level or the privileged exec. Configure terminal, and that moves us through to the next level where we get the config in brackets before the hash prompt. We can exit from that, going back to the hash prompt, which is, of course is the privileged exec or enable level. We can disable, which is the opposite of enable. That returns us to the greater than sign, which is the user exec, which we can log out of, and repeat the login process once again. We've seen how to move between the levels. There are normally a set of commands associated with each of those levels. That's because they share a privilege level. Normally, the user exec level has a privilege level of 1. The enable mode level, or the privileged exec mode, has a level of 15. We can associate commands with a value that represents the level that they must have before that command is executable. For instance, show IP root has a privilege level of 1, which means it will execute at the user exec and upwards. What we could do is we could stop people from using show IP root at the user exec level by raising its privilege level to 15. See the command at the bottom, privilege exec level 15, and then the command show IP root. And I will cover the abbreviations of that command as well. So let's see that by command. Onto router B at the user exec level, show privilege, and we'll see the current privilege for this level is 1. Show IP root, that command works at this level as will some of the other show commands. Move to the enable level, enable mode, password and show privilege. You can see the privilege level here is 15, and again IP root will work. And that's because its current privilege level is set to 1, so 1 and above and it will work. So using the command privilege exec level 15 for the command show IP root, that's now going to raise its privilege level to 15, so it will no longer work at the user exec level. So see, it's still working in enable mode, or the privileged exec if you prefer. So let's disable. And it was previously working here. We used the abbreviated form. That's not working. It looks like it's an invalid input, so put the full command in, and that still doesn't work, proving that the privilege level has been raised. Back to logins. Let's start with a console login, starting with a new router. We can see that by the prompt. That's just got router, as it would by default. No passwords, so as we move through enable level and into the global configuration, where we can actually set the host name of the router. Let's call it router A, and we can now see the prompt has changed to reflect that. Let's come back and do a show run from the enable level. You show the running configuration. We can see there's the host name right at the top. But there is a little bit of configuration in here. There's an IP address of 2, some routing, but we're not interested in that at the moment because what we're interested in is passwords. There's no password set here for line console 0 or the auxiliary port, which is auxiliary 0. Now let us switch over to the auxiliary port. Still on router A. Press return. We should be greeted by the greater than sign, so we're at the user exec level. Type enable, no password set, so we're not allowed in to the auxiliary port. Okay, well we can do some commands here. Show IP route is permitted. This is at the privilege level 1 commands on this router. Exit from there. Let's go back in, plug it back into the console port. We're still on root array, of course. We're at the enable level. Let's raise that up to global configuration. Let's set the enable password. Enable password and a password. We'll simply call it password just to keep it nice and secure. Perhaps not. So come out of there and back over to the auxiliary port. Try again. Put in password. And we're in. So that worked. That wasn't the auxiliary port's password, that was an enable password, and that is working. Okay, so we can see the enable password is set. There indeed is the password. There it is, look, all in clear. So anybody can do a show run can see that password. And if we look at the end, the auxiliary line does not have a password, but we were allowed in because of the presence of that enable password. So that's what it means by saying that the password is not set, essentially. Okay, back into global configuration. Line console 0. So we're moving onto the console port again, once again, in terms of configuration. Password and really secure. Con is the password. We want to prompt that at login, so we use the login word. Control Z. Disable. Exit or log out if you prefer. At that point, let's press return, drag it back in, and we're prompted with a request for a password, which is con or con. Back in enable, of course. Enable has a password, which is password. So we type that in, and we're in. So that's on the console port. Banners. These may well be important for systems from a security standpoint, in the sense that there are times when we need to prompt users to tell them that they're entering into systems that perhaps they shouldn't. You might use the message of the day banner to play out something that is pertinent to that day, and that'll be IT professionals will be changing that on a daily basis. There is also the login banner, which appears each time we try to log in, where there's a password set on either the console or the auxiliary port, for instance. There's another banner, which is the exec banner, which is presented when the users raise their level from the user exec to the privileged exec or the enable mode. So that banner will be presented then. I find that most people are particularly interested in login banners because they're prompted or presented to users when they try to log in, and it should contain a legal message which is usually generated by your legal department to make sure that it's absolutely cast iron. That is also pertinent for when people remotely log in using telnet sessions, and probably more appropriate, assuming of course you've got adequate physical security for your normal devices. So let's see that in practice. Let's log on. No banner prompt to start with. So put in console and then enable and put in password. Config T to global configuration level. And let's set a banner. Banner login. The banner is a login type. We're using the hash as the start symbol, and then everything between this hash and the next hash will be the message. And that message can actually appear over several lines, as long as the message doesn't contain a hash, of course. So here we go with my message. And as you can see, the login banner will appear when trying to log in on the console port or others only if a password is already set. Okay, and hash to finish. That's my message. So that's my login prompt. So let's exit out and press return, and there we go. There's our login prompt in the form of our login banner with the words that match the message. So type in con, we're in, enable and password. There we are, we're in and dandy. What about the auxiliary port? Yeah, what about the auxiliary port? Let's try that on there instead. So move it across. Press return, and we get a prompt straight away with no banner. So the auxiliary port doesn't have it here because there's no password set. The auxiliary port doesn't have a password, there's an enable password, yes. So, into global configuration. One command that's useful is no IP domain lookup. So, just in case you type in a command incorrectly, it'll try and think you're trying to set up a telnet session to that incorrectly spelt whatever it is. And this stops it doing that. Like line org 0, let's set a password then. Orgs, very original. Also need to set the login keyword, so it'll prompt you at login. So let's exit and press return. There we go, there's the banner this time, because we have a password set. We have orgs as the password. We're in at the user exec level, enable, and the enable password, which of course is password. And we're in. So either the orgs port or the console port now, we can now configure this device, and we can also get the same login prompt. So let's disable, and I wonder where we are, auxiliary port or console port. So let's do a show users, and we can see in fact we're actually plugged into the auxiliary port, org 0. Useful command show users. Yep, to show you where you are in terms of how you're actually connected to a device. So come out of there. Let's try again. Got the login prompt. Which port are we on? Show users. I've moved across to the console port. So I've actually physically moved the cable across and logged in through that port. Here we go again. So logging on, moving into enable mode and show run, which is the running configuration file. We can see the enable password is set. Look a bit further down the configuration. We can see the console and orgs set, and all in clear. So not very secure. So one routine we can use is service password encryption, which will randomize those passwords for us. So let's see that in practice. Let's get sort of logged on. Password. Config ticket global configuration. And then let's put in the command. That's service password encryption. I used the tab key there halfway through typing the command. It was unique enough. It's unambiguous, so it filled in the rest of the command for me. That service is now running, so it randomizes the passwords that were previously in clear. They get a level 7, which just means they're randomized rather than properly encrypted. And the other two, which is the line console 0 and line org 0, both are randomized to level 7. Let's take one of those, let's copy that using putty. Let's bring in a utility from Bosun called getPass. Paste that in, and you can see the password is decrypted. Wasn't very secure here, you say in the first place, but this just shows you, if I've got this in a file, if you printed a text file and sent it to me, I could simply take your output, put it through this, and I would get your orgs password, for instance. So it's not secure. It just prevents people looking over your shoulder, being able to see that easily. Right, I'm going to turn that service off because it's a running service. It's done its job. So if I do a do show run, executing the show run at the wrong level, so we use the do in front of it, you'll see that the passwords are still randomized. The only time they will not be randomized is if you typed a new password in over the top of these, and they would actually then be back in clear. You then have to run the service again to re-randomize them. So good. That stops the casual viewing of your passwords. Right, let's get a new password in, enable secret, and we're going to the enable secret password we're going to set to secret. What's the difference between enable secret and enable password? I hear you say, well, let's have a look at the running configuration, and you can see the enable password level 7 are randomized, which again we can reveal And we've got the secret, which is at level 5, which is actually seeded, so to ensure that the output is random, even if we had the same password being put in. So you call it the salt, in fact. So that gives you 2 levels of passwords: secret, which would take some time and effort to break, and password, which is very easy to break. So let's get rid of that and enable password, because I don't need it. If you had both, only the enable secret would be used anyway. So rather than somebody being able to see, you can see that's gone. There's only enable secret left. Okay, now on to remote sessions, so using telnet and virtual teletypes. For that we need a routed connection, so we'll need IP addresses set, but we also need a suitable data connection. We'll use Ethernet 00 for the purposes of that. So we plug that in. Let's do a do show users to see how we've connected to this device, which is router A, and a show sessions, see if we've got any active sessions. We have no active outgoing sessions. There's no virtual sessions. So line VTY0 through to 4, that's 5 separate sessions. Let's give them a password. The password is telnet, and we're going to get you to prompt at login. So let's exit out of there. Okay, back to the enable level and exit one more stage further, and we're out of router A. So router A has a telnet password set, so we can remotely log in from another device into router A. So let's try that from router B. So let's enable and put in its password, which is Cisco. We're on a different router this time. So let's have a little look, see realistically what we can see. So show IP route, and we can see on Ethernet 00 there is a local subnet which is 10.19.00/16 mask. Okay, so if I look at the running configuration for interface Ethernet 00, that's all an abbreviated form there, look, you can see that we've got the IP address as 10.19.1.1. 10.19.1.2 happens to be router A. So if we ping 10.19.1.1, that's ourselves, and 10.19.1.2, that's router A. So we have connectivity through to router A. So let's telnet to it. So telnet and its IP address. There we are, we're prompted with a login prompt, with a login banner and the login prompt for telnet. We put in the telnet password and we're in. So if we type in enable, we should be able to raise up using the enable secret. That's what's set on A of secret. So let's show sessions. This is the outgoing sessions for A. There are none, but there should be some incoming, because it's the telnet session, of course, which is VTY0, the first of the available 5 sessions. Okay. Let's go back to B. We did that by doing Control-Shift-6, releasing those and then pressing X. So if we show users, we can see that we're logged on the local console port, and if we use show sessions, we can show that we're externally connecting to router A using telnet. So press return, we go back to A, so we can then again show users, so we can again see the telnet session coming in. Let's exit from A, and that closes the connection from A back to B, and that's the end of that telnet session. So continuing telnet, let's again with router A, go into global configuration, line VTY0 through to 4, so it's telnet configuration. Let's set the login now to login local. So this will now require a username and password. Now we only have a password set. So let's show run, pipe that through, begin, where it starts with line console, so that's matching line console in the running config. That's where we can see the output starting, and we can see the telnet with login local. So there is a password set, but there's no mention here of a username. So let's go to router B. Let's log in the normal way. I'm just going to raise this up to global configuration. I'm going to use the IP host command to set a relationship between router A and its IP address. That's router A as a name and its IP address of 10.19.1.2. So I'm effectively setting up my own host table within the router, like a /etc/host as you find in Linux. So show sessions shows there's no outgoing sessions as yet, so let's telnet to router A. It requests a username. We don't have one set, so it won't accept anything that I put in there password wise. Returning to router B, show sessions, so it shows that it has an outgoing session, it thinks at least to router A. Well, let's disconnect that because we don't need that as yet. Show session now shows there's no connections open from router B. Let's exit from there. So going back to router A, so let's log on to router A, enable secret, and I'm going into global configuration again. I'm going to set a username to Dan Brown and a password of, I don't know, Da Vinci perhaps. That will actually be stored in clear. Let's have another one, Guy, but this time instead of password put the word secret and forks. Just like enable had password and secret, we can do that with username as well. So if we go and look at the running configuration, and towards the top of the configuration file we should find the enable secret, but just under that we'll find the usernames and passwords. So we've got one for Dan Brown, which is a password, and we can see that the actual password is in clear, whereas Guy is a secret, and just like the enable secret, is salted and effectively encrypted. So would therefore be the preference. Again, just reinforcing the telnet is set to login local. So if we try and remotely log in, it should request a username and password. So once again, let's do that from router B. Let's telnet to router A. So it's useful using names because hopefully you know who you're dealing with. Guy and forks. And all being well, we're now logged in to router A. Raise ourselves up to the enable mode using secret. Show users, and we can now see the active VTY session for the user Guy. So let's see if we can clear that line. 66. Won't let you do that because that's the line that you're on. Yeah, it's currently the one that you're on. Now, here on router A, get back to router B. On router B we can see that we've got a session active to router A. We can disconnect that. Confirm, and that's now gone. Back on router A, if you look at show users, there's only the line console now. The telnet session has disappeared. Yep, confirming we are here on router A. On router A, up to global configuration, line VTY04, one of the things that we can do is we can set the transport for the telnet session. We set that to none. We could set it to secure shell, but we'll set it to none. And that will actually prevent anybody from telnetting in. So if we go back to router B, and we tried to telnet in, against router A, remember that was working before, we can see the connection is refused. The other alternative is to use secure shell, as an example of the secure shell settings on screen. Well, secure shell or SSH is for another day, but hopefully that's been a useful introduction to logins, passwords, and a few other ancillary commands along the way. Many thanks, and look forward to seeing you on one of our other videos very soon.